Hello guys, in this video, we will create an interactive door system inspired by Minecraft and implement it practically inside Unreal Engine. First, we will create one blueprint actor for the door and another one for the interactive button. Now, we will open the door blueprint and create the door inside it. I will add a cube to serve as our door, but you can download a door mesh from the internet or use any mesh you prefer. Now, I will add a door frame on both sides. Now we need to add a cylinder to act as the pivot point for the door. If we rotate the door mesh directly, it will rotate from the center, so we use the cylinder as a pivot to allow the door to open correctly. I will scale down the cylinder and place it at the edge of the door to serve as the rotation point when the door opens. If you make a mistake and want to go one step back, press Alt+Z. Now, we make sure that the cylinder is not directly attached to the door. Then, from the Components panel, we drag the door under the cylinder so it becomes its child, allowing us to control the door through the cylinder. After making the door a child of the cylinder, you will notice that rotating the cylinder will also rotate the door along with it. Now, we will compile and move to the event graph to start the scripting. Now, we will add a custom event inside the door blueprint so it can be called from the button blueprint. A custom event is a manual event that allows us to trigger specific actions whenever we need, such as opening or closing the door when the button is pressed. A custom event does not run automatically. It only executes when it is explicitly called. Now we will add a timeline. A timeline acts as a time-based controller that allows us to smoothly change values over a specified duration. For example, we can set it to 2 seconds and define a curve, and the timeline will gradually update the value over those 2 seconds instead of changing it instantly. Now, we will double-click the timeline with the left mouse button to open it, and then create the timeline curve that will be used to open the door. We will add a float track, which will serve as the timeline used to control the door's movement. We will set the duration, in seconds, over which the door will open. We will add a float key to the timeline by holding the Shift key and left-clicking with the mouse. After adding the float key, we will set the time to 0 and the value to 0. This will be the starting point of the door. We will add another float key and set it at 2 seconds to mark the end of the timeline. This makes the timeline duration 2 seconds, with the value changing from 0 at the start to 1 at the end. After that, we will use the zoom controls on the sides and top to view the entire timeline. You will see one float key at the start and another at the end, connected by an ascending curve that represents the duration over which the door opens. Now, we select one of the float keys, then hold the Alt key to select the other one. After that, we right-click and set them to auto to make the door opening animation smoother and more natural. Now, we save our work, and with that, we have finished creating the door opening animation. Turn to the event graph and use the cylinder that we set as the door's rotation pivot. Now, we will get the current rotation value of the cylinder. After retrieving the current rotation of the cylinder, we will now assign a new rotation value to open the door. Now, we can see that the axes are combined, so we right-click to split the axes. We want the door to rotate on a single axis only. Specify the axis around which the door will rotate. We return to the viewport and select the cylinder to determine the direction in which the door will rotate. As you can see, the door rotates around the blue axis, which is the z-axis. You can check which axis an object rotates around in the Details panel. After identifying the axis around which the door will rotate, we return to the event graph and add the y and x axes as they are in the new position. We will not modify them, the change will be applied only to the z-axis. The change in the z-axis will be in the new position. We will use a lerp node to apply this change, which provides two values, A and B. Value A will be the door's current position, while value B will be the new position where the door will stop after 2 seconds. I will set the new value to 70 degrees, though you can choose any number you prefer. This value represents the rotation angle of the door. After that, we will connect it to the timeline we set up. Make sure that value A is 0, which is the door's current position, so that the change occurs only in value B. Now, we compile and save our work, and with that, we have finished programming the door. The only remaining step is to connect it to the button. We enter the blueprint for the button and add a cube to serve as our button. As usual, you can use any mesh you like for the button, whether a pre-made mesh or a custom design. Now, we will add a box collision to the button, which serves as the interactive collision that will respond to the player. We will place the button in the level, and then enter the event graph to program it. We will select the collision, then right-click and choose on Component Begin Overlap. We will specify that the player, i.e., the character, is the entity that will interact with the collision. We will use a sequence node, which allows us to create multiple code paths, branches, that execute sequentially. This enables us to perform several different actions within the same event efficiently. From the first path, we select Play Sound, which represents the button press sound. You can choose any sound you prefer for the button interaction. From the second path, we will connect to the blueprint of the door. we will use the getActor class node. And in the actor class field, make sure to select the door's blueprint with the exact name. It's essential to ensure it's the correct door blueprint for it to function properly. From the return value, we will call the function, or custom event, that we created inside the door's blueprint. Now, we will add the door opening sound, but it's important to use a do once node to ensure the sound plays only once. Without do once, the sound would continuously repeat for the 2-second duration of the timeline we set up in the door's blueprint. This happens because the sound is triggered after calling the door's function, so it would repeat each time the door's code executes. Using do once ensures the sound plays just once, synchronizing correctly with the door opening animation. We will save our work and test the door to ensure everything functions correctly. As you can see, everything works well, but now the door should close automatically when we move away from the button. Now, we return to the door's blueprint and add a new custom event to perform a reset. We will connect it to the timeline with reverse enabled, so the timeline plays backward, effectively reversing the door opening motion. After that, we will call this function from the button's blueprint. In the button's blueprint, we will select the collision again and right-click, but this time we will choose on component end overlap. Now, using on component end overlap and verifying that the player is the one exiting the box, we will connect to the door's blueprint as before. This time, however, we will call the reset function to automatically close the door. We will now add a delay node to postpone the closing action for 2 seconds before the door closes automatically. This ensures the door waits for 2 seconds after the player leaves, and then closes itself. After that, we need to connect the reset function at the end of the code to reset the do once node for the door opening sound. This way, after the door opens and the sound plays once, and when the player exits the collision and the door closes, the sound is reset. This ensures the sound is ready to play again the next time the door is opened. We will save our work and test the door to ensure everything functions correctly. As you can see, everything is functioning smoothly and correctly. In the corner of the door, the cylinder we placed to control the door is still visible, and its appearance doesn't fit the scene. Therefore, we will hide it. Return to the blueprint for the door and enter the viewport, then select the cylinder. Next, in the Details panel, locate the hidden in-game property and enable it. This way, the cylinder will be invisible during gameplay, but it will still exist programmatically and can be used in any door-related logic. Once the game is played or packaged, the cylinder will not be visible to the player. This concludes our tutorial. If you found this video helpful, please like and subscribe to the channel to stay updated with future lessons. Don't forget to share your thoughts and questions in the comments. I look forward to seeing you in the next tutorial.